Hello, everybody, and welcome to today's vOLTHA TST. Thanks for joining. As usual, the call is public and recorded and will be shared on YouTube. So today we have two fairly important topics. One is going to be some little changes that we are proposing on flow delete based on some debugging that we have done at ONF around ONU delete and rediscovery. That was a Deutsche Telekom use case. And the second one is a proposal from Nazia on the microservice controller for vOLTHA. So first up, I'd like to give word to Elia, who's here with me, to talk about the ONU rediscovery and some of the delete scenarios he has encountered.
Hello, everybody. About the ONU rediscovery scenario, we saw that a deleted ONU that comes up again and is discovered again left some rules in ONOS that couldn't be removed completely. And with some debugging, the problem seemed to be some errors about the deletion of resources that were already deleted, like the device that was not there anymore generated an error. But these errors are not really errors in the case of a deletion, because if you want to delete something and it is not there anymore, we can proceed deleting the remaining resources and just logging that the ones that are already missing are not there anymore. For this reason, I pushed a couple of patches in one for vOLTHA and the other one for the OpenVOLTHA adapter to change a couple of errors into just logs. And as I said before, these let the procedures continue and delete remaining resources. Right now, I have there are a couple of errors in the verification, but I will fix that soon. But I think you can start to check the patches.
Yeah, the idea behind this is that the delete should be really an idempotent operation, meaning that if we're trying, as Elia said, if we're trying to delete something that it's already there, it should just say, I don't have it, so your delete is successful. So what I would ask everybody is to go and review these two patches. They have been tested both manually and in a BBSIM based test. We currently are seeing some issues in the verifications that is independent to these patches. It's due to a change that we have introduced in the tests on how we reuse the ONOS SSH session. So if you do see a -1, don't shy away from making the review of the patches, but please proceed. Especially, I would like some of the core experts like Ken and David, if you could take a peek at these, and Girish, maybe yourself for the OpenVOLTHA adapter. Is there any disagreement on, especially the assumption that we are making that we can return success if a delete of something that is not there arrives?
The only concern I have regarding this is, do we have a way to differentiate whether the error we receive is a not found or something else went wrong and the item is there, but I cannot delete it?
Yeah, in both cases, both in vOLTHA core and the adapter, first of all, this is only done for the delete operation, and if the error is a not found error.
Yeah, sorry, I didn't look at the code before asking the question. It's pretty obvious.
Just to make it clear, it's only we can say ignored, but it's not ignored because it's logged and it's checked, but it's only done if the error is not found.
A quick question I have is, you're deleting from an ONU or OLT device, or it doesn't matter?
Sorry, can you repeat?
Is this a deletion on an ONU or OLT device, or it just doesn't matter in your use case?
It's in this case in the core. It's for both devices, for the ONU and then for resources about the ONU that were on the OLT, I guess.
Yeah, so this particular case that we are testing with is an ONU delete. So as per OMCI specification, what happens is that if you do, the ONU will always send out indications when it is on a PON. So the Deutsche Telekom had a use case where to completely purge the ONU from vOLTHA, they would do an ONU delete, okay? But what that results in is that we should purge it from vOLTHA. The ONU then comes back through an indication acting as a completely new ONU. So in this case, this test has been, this functionality has been enhanced for the ONU. It still needs to be working for OLT device deletes and things like that. And that is why we have been testing it with the BBSIM 50+ tests. Does that answer your question, Ken?
Yes. So if I go if I delete an OLT, so there's a set of actions that happen, which one of those actions is to go and delete the child devices, the ONU devices. If the OLT is not present and not found, so we go and delete all the flows, and I assume that's okay. We'll get the same response from the ONU as well, right? Something is not found. Could we get a situation where the OLT for some reason say not found, but the ONU are still there?
Yeah, I think, of course, this needs to be tested, but I think that on the core, only the devices that are filtered. When a rule to delete arrives, it is decomposed, and for each of the decomposed rules, there is a check to see if the device is found. And only for those that are not found, that is, we can say, ignored. But for the devices that are still there, it should proceed as usual.
Ken, there is also a difference in how the system handles ONU delete versus OLT delete. Because in the case of the ONU delete, we go port down in ONOS, and ONOS goes down, deletes the flows. Instead, in a device delete, everything is automatically purged from vOLTHA in the transitions. And also, ONOS then subsequently, when the device goes down, it also completely purges internal state. So in the OLT, or actually parent device, is a little bit easier because it's more of a like everything goes operation. Here, instead, is a little more complicated because it's a child device. So in respect to the OLT, it's simpler handling. Everything will go. In the ONU, you have to do a little bit more checks.
Oh, okay. So it's so that that delete per se, that would be the same behavior if it was a delete false, right?
Yes, but it's a delete false triggered by the southbound effectively.
Triggered by the southbound means
In the
the
sense-
not
in the
found.
sense-
The not found is kind of a delete false.
Yeah.
Okay. Okay, it's all right then.
Okay. Any other question on this topic? Otherwise, as I said, please do review the patches. They're not that big, and our hope is to get the system tests verification passing hopefully later today, worst case tomorrow, and then we can make sure to merge these whenever some review come, and we check that all the tests are passing with these changes. Okay, and if not, let me proceed to the next topic on the meeting, which is Nazia's proposal for the microservice controller. If you guys remember, there was a discussion on generally the state of ONOS and what we can do to improve the scale and functionality and performance of the system. And some of the same thoughts apply to this proposal. So the same concepts of we want less resources used, we want a microservice approach, we want the system to scale better. All those items that I highlighted in this section of the document that I have, like the existing implementation limitations, apply to the proposal that Nazia is making. Mahir, Taner, do you want to take it from me and share your screen?
Yes, before giving the stage to Taner, because he will go through the document, I want to summarize the proposal. So, you know, we want to implement the new SEBA controller, and we had started the work before, and after this ONF proposal came up, we aligned our design with it, and we want to agree with the community on the design. So start the implementation according to this design. So that's why we're bringing this proposal of implementation. And Taner, now I'm giving stage to you. You can go through the document.
Okay, thank you. I'm sharing document. Okay, as Mahir and Andrea summarized, we have the same goal, just like they mentioned. Same concerns apply that the Andrea mentioned in his document. Those are main concerns that we would like to address with this replacement project. We would like to go with a much simpler design and avoid complex implementation designs. We go with the microservice-based architecture. We think that the network applications and other components all should be separate containers. The container-based design enables the community to utilize different programming languages or frameworks for each component separately, as long as the design and the interface and the behavior of the component is well defined. We go with the gRPC for our main form of communication technology. We would like to avoid data duplication as much as possible, because the current ONOS and vOLTHA implementations storing the same data with different formats on their own domain. We would like to address this issue as well. And we would like to go in an iterative approach. In this phase in the initial phase of the replacement project, we don't want to make any change on the vOLTHA components or minimum changes. Other improvements that we discussed on vOLTHA requires much more effort and changes in this part of the project, and those can be addressed later phase of the project. The main view is very similar to the Andreas design proposal. This is basically two separate stacks is forming a SEBA stack. This control stack is a functionality of the ONOS that's running right now. Those are separate containers, as I mentioned earlier, and there's an additional component, a new component that we introduce here. This is that we call control core. This is the main component and a kind of a gateway to the RV core gRPC interfaces. Its role is basically a gateway to the control stack applications and the vOLTHA components. As you know, the vOLTHA stack supports multiple OLTs, so the new control stack should also be supporting multiple OLTs. But for the initial, at this initial part, maybe we can change later. But the current ONOS architecture supports multiple vOLTHA stacks. I mean, one ONOS controller could support multiple vOLTHA stacks. But in this new design, we prefer to go in a one-to-one relationship with control stack and the vOLTHA stack, while vOLTHA supporting multiple OLTs. For high availability, for initial phase or for the first phase of the project, we go with the fail fast, recover fast approach, much like the vOLTHA. Traditional strategies like N+1 to N+1 high availability will not be used, maybe addressed later if required. So basically each logical component will have one running instance. If one instance failed, new instance will be instantiated quickly. That's our high availability model for now. In production, we are running separate vOLTHA stacks for each OLTs. It's easier to troubleshoot problems, safer operations, and etc. And it's a little bit more resource consuming. But we probably go for this approach in our production setup. So the new design should support this deployment setup as well. For more detailed view, this two new components that we are going to introduce in the picture. The first one is a control core that I mentioned. This is basically is a set of service that are opening to the network applications. First one is the package dispatching service. This is just basically a packet in and packet out operations. Flow group meter service is like flow installation, meter installations, and their querying their status. And the other one is the device service. This is just a pass-through service, you can say, because it's just passing through the device service to the RV core interface. It's not doing much in this design. The other one is the core control core library. You can consider it as much like a vOLTHA lib Go component. This is an enabler utility library. It includes some packet parsing, connection management, and etc. It's just a helper library for the applications to make their lives easier. So for the last part is about the data ownership. As I mentioned earlier, we would like to avoid data duplication as much as possible. So we would like to have those separate stacks could see the same data view, but we would like to also have a data ownership, a strict data ownership between those components. The last meeting that we had with Andrea and Grish and guys, this data separation made sense. That can change, but for the initial phase, this is the way we will like to go. Control stack should own the logical flow data, as it's the generator of this data. And if network applications would like to store their own data, it's going to store in this key value store that's dedicated to the control stack. Logical device ports, physical flows, physical device ports, and those kind of data will remain on the RB core vOLTHA side. If any application or any core service would like to access those data, they will like to go through the RB core and read it from there, or manipulating data through the RB core interfaces. So this is the main concept and the thing that we have talked and agreed upon for now. I would like to cut this presentation as short as possible to have a time to discuss or talk about. So this is basically the end of the presentation.
Could you go back to slide 2, the drivers, please? Thank you.
Okay.
So looking at these drivers, this is a rewrite because the current ONOS implementation, monolithic, I get that. It's just too resource intensive for a lot of reasons. Is that kind of the main driver you're seeing here? Is there's kind of an impedance mismatch as well as a technological mismatch between ONOS and where you see where we need to go?
Actually, I would not like to repeat the reasons that the Andreas documents in here, because all the things that he said on those documents are very valid, and it applies to our own motivation to change the ONOS. And those are just the concerns that we'd like to introduce in this design, additional to the Andreas. There's some of them matches with the Andreas concerns as well. Okay. And I would like to amplify and put them in here.
And when you looked at this, did you look at kind of MicroONOS? And I know MicroONOS has its own path it's on to support other ONF projects. But did you guys consider going to MicroONOS, and what were some of the reasons that you kind of chose to build your own packet handlers and or kind of went this direction?
We checked on the MicroONOS too, but we couldn't find much things to common things to use it in here. But there's another reason that we will not go with the MicroONOS, because we will not like to combine two separate projects because their timeline, their priorities could differ in time, and those are hindering our progress in time that we face in ONOS. So we like to stay away with the current projects, and we would like to go to a specific SEBA-specific component in this new design.
And
Andrea can correct us, but I think MicroONOS doesn't have any packet handling, say flow handling, etc. Functionalities in it. It's some kind of rig controller, not a SDN controller.
Yes, at the moment we don't have in MicroONOS packet flow or kind of device handling in this specific sense. One idea with the ONF sponsored design was to create reusable elements for MicroONOS as well. But I have to say ONF at the moment does not have resources to pursue this. So yeah, it was, I see your comment, David. It would be nice to include this. And that was our original idea, but us as ONF don't have resources to put behind this. And thus, I do see Mahir's point and Taner's point in creating a separate component that does not have dependencies on other projects' roadmaps.
Yep, I understand that. On slide 3, I was looking at the communication. I think it's slide 3, the communication between what you're calling the control stack and the vOLTHA stack, and it's gRPC. So are you planning to change that gRPC interface? Because you're eliminating the OpenFlow agent, which I'm fine with. I have no problem with that. But does kind of the Ethernet switch abstraction make sense anymore? And if so, do you see that gRPC interface changing to no longer kind of follow this Ethernet switch abstraction, but be more cognizant, if you will, of the relationship between OLT and ONU, and kind of, I'll call it out as more BVF type interface?
It's a very good point. We discussed that, but like I said, the previous design, and I mean with the iterative approach, we would like to go with the same logical device, logical flows, logical data model. We would like to keep that for the initial design to make things simple, to make this step by step. But it's a fair discussion point, I think, to decide whether we eliminate all those logical switch concept and we go much to the BBF type of design. It could be a good discussion, but we would like to go in the initial phase to a solid replacement for the ONOS functionality only. So this gRPC interface remains the same for now, at least.
How do you envision interacting, the user or the operator interacting with the control stack? Is that going to be kind of its own API, its own CLI, its own GUI? How do you envision that?
Well, we initially put another layer on top of this stack, kind of an ADF layer that includes a CLI interface, a REST interface, and presenting all those views to the external system. It could still be useful for this initial phase of the project, but for our production lineup, we already have an integration, and we already have a logical component, a service logic components directly communicating with ONOS. That's why we leave this to the ONF decision, because we're not going to use that component if we put that component in here. If it's needed, it's going to be something like this, because after changing the design, like I mentioned, there will be more than one control stack per edge. So if you would like to have a single view of the whole control stacks with a single interface, it should be something a common components view. But we didn't address that part for now.
So presumably this means there is a control stack gRPC or control stack API that people are going to access. That's going to be
David, your
Yeah.
input here is important because currently the control stack or ONOS and applications have interfaces at the northbound. They have some APIs, and we should, keep these APIs on the northbound of the applications. But on the other hand, ONOS has a CLI, and we won't be having a CLI here. We plan to use Vault CLI here to augment it with some comments for applications. And what's your opinion on that? Because
okay. I mean, that's fine. There's a gRPC endpoint that's missing that comes, the kind of the northbound API to control stack. And the question is, in this microservice environment where today you have, 4 microservices, network apps, potentially there could be additional apps added. And the question is how, if those apps have new gRPC messages, how does that work, right? Is there a gRPC endpoint for each app plus a gRPC endpoint for control stack? I think those are some of the questions that are going to have to be looked at.
Okay, I'm currently, this can be a gRPC service per application.
Okay.
If any implementer wants, we can leave it to the implementer to put a layer on top of it as a common, gRPC API gateway or something, but we're thinking now to have a gRPC service for each application.
As long as the data in the applications don't overlap, that's
Yes.
fine having a gRPC. I assume they can, again, they're services, so they can all go over the same port and same endport, gRPC endport, just be different services.
Yeah.
Or if they're microservices, there's several. Okay, fair enough. Is ONF planning to do anything, or just leave the northbound API? And if anybody wants, you said there's going to be vOLTHA extensions potentially. All right.
Yeah, at the moment, I think we are going. Our idea was to keep changes to a fair minimum in respect to what was there right now, to keep the REST API. I think what Mahir said is fine. If anybody wants, there's always adaptation layers that can be built.
You're going to keep the REST API for each of these apps?
No, the idea was to, we didn't split it exactly like the Nazia team is doing. So not each app had its own API. We were trying to keep a single facade towards the northbound, but that was something that we didn't really have completely designed even in our proposal.
Okay. And that the main purpose of that was to keep compatibility with the existing SIBA implementation?
Yep.
Yeah, I'd almost see that as a, if each of these applications are going to be a microservice and each are going to have their own gRPC interface, I think that REST API almost becomes an adapter to it.
That could very well be.
All right. Now, one thing, because these are all microservices, for packet in handling, we're now going cross-process for packet handling. I guess we're going cross-process anyway, but we're now jumping twice. One from the vOLTHA stack, multiple cross processes, I guess, because they're microservice containers as well. And now we're adding some additional latency in the packet processing. Has that been thought about? Has that been just, we don't think that's going to be an issue?
Yeah, David, let me explain something about that. I mean, we talked about that, and we discussed something about that. And this control core here, this we thought that this application can be separated to different components in the later phases. Currently, we're keeping it there because of the design concerns that the Taner said. I mean, these were the guidelines for us currently, and we don't want to change too much in the vOLTHA core currently. But in the future, this control core may be divided in some parts, like we can move the flows into the RW core, the flow group service, etc. And most importantly, we can separate the packet dispatcher service here and connect it directly to the agent on the OLT. So we can get packets directly from agent and go pass them to the applications. But in current iteration, as we said, these services are there. This may put some, I don't know, we expect it shouldn't put some extra delay, because still it's going through vOLTHA and then OF agent and the application. So it's only the control core instead of OF agent there. So
you're expecting about the same level of delay.
Yes.
Okay.
Yeah, but in the future, we think that we're better to improve this delay from packets going through the vOLTHA core to controller and coming back. So we can improve there, and we can dispatch packet service there to connect directly to the agent.
Well, this is what Mahir was mentioned. This is the design that they presented, but we also talked about this one too. So instead of creating another control core component, we could implement this inside an RB core. This could be another option. And the another option that we like was this one. It's a much fair design to separating the logical responsibilities. Those boxes will be only responsible with the OLT device configuration, and this package handler is only handling and dispatching packages. And this could be another option. But like I said before, we would like to go step by step. So we first introduce this layer to have a minimum impact on the vOLTHA. But maybe we can move to this one or eventually this one in the later phases.
Yeah, I kind of like alternative 4 at the end. All right.
Yeah.
Although
So-
it does, this slide does raise another question, because you put Java in there. I was just, why?
I have a question on the alternate 4. So
I'll just those are our concerns. It's just
yeah. It just,
yeah. It's just
okay.
it's just not about this one. This is an internal document. I just want to show the concept.
But these designs are not the today's concerns. I mean, part of the today's proposal.
Yeah.
Let's go to the
so we should more stick to the I just want to show the idea. So the current proposal is like this, at least for now, and it's open to discussion, of course.
Is there any consideration for for failure, like those the AAA's DHCP containers, are those like stateless containers, or stateful? Like if they go down, what happens?
If they could be stateless if possible, but if any of those applications should store a state, it should store on the key value store. That's what we thought, at least. If it's too expensive to reach to the store on each package, on each operation, we could put some of them on the local cache on each application. But the main idea is to utilize the store to store their states.
Okay, so if we want if it's stateless, so you can scale
Yes.
without any worries. If it's not, then it's then you have to put additional logic there.
Yeah, for this part, we would like to keep things simple. So we would like to think that there's only one instance for each application. If we like to scale them separately, like you mentioned, we need to address them as a separate thing, but we didn't discuss that yet.
Okay, so currently, if one of them goes down, it's a slight loss of service until it's come back up.
Yes.
Each of the service will be, investigated and separately for, to make them stateless, or if they will be stateless or not. Of course, if they would be stateless, then both the reconciliation or the scale would be easy, So, but if the application has some states to preserve needs, then, as Taner said, we have to store the states on the KV store. I think currently vOLTHA may have some states on it, the vOLTHA application, but the others, I'm not sure. I think they can be stateless, but each should be investigated.
There is some state regarding, for example, the AAA app has some state in relation to the state machine for the authentication. I believe the DHCP app keeps some state again for the status of the DHCP exchange. I'm not sure about the IGMP app.
Okay, we haven't deeply investigated them for this perspective, but it will be.
So what would be the interface for the apps to talk to each other?
All interfaces will be gRPC.
Okay, so we'll come up with a new interface. For example, I think in the current thing, there is an interface so that one is the host service, right? Using which the Mac Learner app is passing information to the vOLTHA app, or even the event service using which I think some events are passed to the Kafka app, which is dumping it onto the Kafka bus. So what about those interfaces?
I'm not sure about the Kafka. Taner, do you have any idea if we continue to use Kafka to events?
Maybe outside of the control stack, maybe we can put some Kafka interaction here, but other than that, between the application, I don't think we need Kafka. But if it's required, we could have a gRPC interface among them, or if it's just a data that they like to read, they can directly read from the key value store, because they're a common key value store for all applications. We haven't thought about much on the application level per se. We would like to have the general design concepts, but so we would like to apply and go investigate on each each application later on. But your comments are more than welcome.
Just a quick question. Between the control core and the vOLTHA stack per se, who initiate the first connection? Like in OpenFlow, it's the vOLTHA stack that initiate that connection to all nodes today. In this case, how that connection will work? Does it have to be pre-configured somewhere?
Probably pre-configured, because they'll be coupled with each other, one-to-one relationship. So each stack will be aware of each other.
So in the ONF initial thinking, the idea was to deploy a sidecar to vOLTHA that had knowledge about the endpoint of the controller.
So have knowledge, it means that it will initiate that first gRPC communication with the control core, right?
It really depends, because OpenFlow is a stable SSH, it's a stable connection, and it's kept open between the two components, while in gRPC is more an ad hoc communication. So having knowledge to me means knows the endpoint, and then it's up to him on how to use it. Maybe it's not vOLTHA that initiates the first connection. Maybe it's the controller for some reason. It usually is vOLTHA, but it doesn't mean it has to be, given that gRPC is not as a persistent connection as OpenFlow, at least in my mind.
Well, I mean, that's one of the questions, right, Amy? You could do a gRPC streaming connection between the two, and we've already got precedents in vOLTHA itself that you specify the service to which you want to connect, right? So it's perfectly reasonable to say, as part of the configuration, you either have the stack or, the vOLTHA stack say, hey, go create the connection to the control stack. Depends whether you want a top-down model or bottom-up model, who you configure to talk to who.
As far as I know, for the current implementation, there's another component here. No, it's an OF agent, and it's the one who is responsible of having the vOLTHA endpoint in its configuration. So actually, the OF agent was initiating the connection to the RV core. We're probably going to keep that approach, at least for now, but it could be changed in the future. But for now, probably it's going to be starting from the control core.
So the functionality. Go ahead.
Do we have to maintain a persistent connection, by the way? Just thinking.
I think for the package dispatching, because there's a gRPC stream between the agent and the RV core for package dispatching, package in, package out, and some change events from the RV core, and those requires persistent connections.
Yeah, for the packet handling, yes, I think we have two, but for the other things, for example, for the vOLTHA API, I think we don't have to maintain a persistent connection to ask something from vOLTHA northbound core. It should also work like a HTTP mechanism, like request and response.
Yeah, standard query interface does not require consistent connections. Yes, it's correct. Just two-way connections, like a streams or channels requires connections. Those are the package and events coming from the RV core.
So
right now,
go ahead.
so right now, right now, we have some troubles on maintaining those connections, right, between the vOLTHA components. So we are putting some heartbeat mechanism to keep the connection open between the vOLTHA components. So having lots of gRPC connections between the components, I am thinking of that there might be some issues also. So maybe we should think something else. Just thinking.
Yeah, on another note, if I get it right, you kind of mentioned that the functionality that exists in OF agent currently, you'll put that functionality into the control core, correct?
No. It's just a similar component in the old design. That's what I mentioned. The OF agent. OF agent was basically connected to the RB core and connected into ONOS and making a protocol translation. You can say.
Yeah, I understand that.
Yeah, the only similar part is the way they're maintaining the connection between the RB core. They're both OF agent and control core, both using the same gRPC interface, same services, and etc. In this concept, they're similar, but on the northbound, some they're completely different.
Yeah, that's all right. I just wanted to clarify what were like some of the functionalities, the southbound functionalities of OF agent will still be there.
Yes, exactly.
And all those containers are written in Go, right?
Well, this thing will be up to the implementer, I think, because in our case, it could be different programming languages, different technologies. As far as the behavior is well defined for each component and their interfaces are well defined, it really doesn't matter which language they're using, which technology they're using.
Well, for packet processing, you want it to be fast, right?
Yes, it's correct. So that's why the one option was to code this service inside an RB core to make it much more slick and much more faster. That's an option we are considering for now. Maybe we can remove this component completely. You can consider this as a logical function for now. It could be a separate container or a function inside an RB core. It's to be decided.
Okay.
Okay. I think there is very good feedback here. As I mentioned before, ONF has at the moment no resources to pursue swapping ONOS. And a requirement from Deutsche Telekom around FTTP, as you all know, mandates that we still release 2.10 with the current generation of ONOS. So that's what we are at the moment at ONF focusing on. So there are out there other implementation of something similar to our proposal and something similar to Nazia's proposal. But given that ONF has no resources to commit to this, my take is that this seems a good proposal, and it goes along the lines of the stakes that we have put in the ground for our initial thoughts in the document that I shared some time ago. So I would encourage Nazia to proceed. And then when we at ONF have resources to dedicate, we will then evaluate the next steps on our side, and possibly one of the next steps could be taking this open source or taking other solutions open source. As I said, given that we have no resources at the moment and we are not going to focus on this, I don't want to hold anybody back. So I'm encouraging Nazia to do this. The key element that I want to stress out is that, and this is the only thing that I ask of you guys, is that you make no changes to the proto of vOLTHA in the northbound at this given point in time. Or if you make changes, that they are upstreamed and backwards compatible, so that the API stays in the open and we are not diverging from an API perspective. That is the only ask that I have. Would that be okay, Mahir?
Yeah, that's fair on the northbound of the control stack and southbound of the control stack. We will try to live with the current products, okay, and current northbound APIs, etc. We believe that this is also key for us to be in line with the community, you know. Andrea?
Yeah, okay. That's okay for me. Sorry, I was not answering because that was okay for me. So, as I said, I encourage you guys to go ahead, and then when we have resources to dedicate to this, we will evaluate the state of things. We are always very open for debates and discussions here at the TST, especially if you find things out, because this could lead to announcements to vOLTHA as well, and we're more than welcome to accept those. So just go ahead. I think this is a very good proposal, and you got good feedback from here. And if you want more, we're always welcome to discuss.
Thank you very much, everybody. We appreciate your feedbacks. It was a very fruitful discussion. Thank you to all.
Okay, is there any other comment, any other point? No? Okay, then if not, thanks everybody for joining. As usual, I'll publish the recording and we'll talk again next week. And thanks for the great work. There are some other topics on the agenda. We will get to them next week. Thanks, everybody. Cheers. Bye-bye.
Bye-bye.
Thank you.
Bye.